All right, we are going to complete these problems about molarity in stoichiometry. So first I'll read to you the background and then we'll complete the problems. So we'll start up here with this paragraph. On average, an adult human's stomach contains 75 milliliters of stomach acid. It's a range, but that's kind of in the middle. That stomach acid is hydrochloric acid, HCl. The concentration of stomach acid is 0.16 molar. Mr. Beaker has an upset stomach, so he opens the medicine cabinet to find 3 antacids. So antacid is like anti-acid, so it neutralizes the acid in someone's stomach. Antacid A is in tablet form. Antacid B is a concentrated solution, 0.25 molar, and antacid C is a diluted solution, 0.11 molar. The main ingredient in each antacid is magnesium hydroxide, and it reacts with hydrochloric acid like this. So now we'll shift our attention down here, and we have the magnesium hydroxide plus 2 hydrochloric acid makes 2 waters and magnesium chloride. And if you remember from when you learned about acid-base reactions, every acid, so here is your acid, here is your base, and then they make water and a salt. So this is a neutralization reaction. So what we'll do today together is to calculate the amount of each antacid Mr. Beaker would need to neutralize the acid in his upset stomach. So apparently he has time on his hands to calculate, but we'll go ahead and do this. So antacid A, we're going to be calculating the grams of magnesium hydroxide needed. Antacid B, we'll calculate the milliliters of the concentrated acid, and antacid C, calculate the milliliters of the diluted acid, or the diluted base, base in each case, magnesium hydroxide. So here we go. One reminder is that when we do these calculations, you will never begin your dimensional analysis with molarity. So in each case, we're going to begin with the 75 milliliters of acid in a human stomach. So we'll start off with 75 milliliters of the hydrochloric acid. Now this is going to be a pretty long problem, so make sure you write nice and tight. Here we go. So we'll convert this into liters. 1 liter of hydrochloric acid. And now is the time for the molarity of the acid. So from way up here, the concentration of stomach acid is 0.16 molar. So for every liter, 0.160 moles of acid. And notice, just like always, we have milliliters of acid canceling, liters of acid canceling, and so next up will be our moles of acid canceling. We're trying to get to the grams of magnesium hydroxide, so we want to use a mole ratio between the acid and the base, 2 to 1. So for every 2 moles of HCl, there's 1 mole of magnesium hydroxide. Okay, and then would come up with grams of magnesium hydroxide. So for every 1 mole magnesium hydroxide, now I'm going to use my periodic table to calculate the molar mass. Well, I'm going to look it up online, but I'm going to calculate the molar mass of magnesium hydroxide. And it's 58.32. So we'll go 58.32 grams of magnesium hydroxide. Okay, so now we have moles of acid cancel, moles of oh my goodness. I hope you caught that before I did. Magnesium hydroxide would have a 2. I think I was a little distracted. Okay. And then we would have moles canceling and then finally end up with grams. So when we calculate this out, we'll do 75 times 0.16 times 58.32 divided by 2 divided by 1,000, 0.350, I guess, with sig figs, 0.350 grams of magnesium hydroxide. And there we go. So that's our first answer. This is how much Mr. Beaker would needed to neutralize all the acid in his stomach. He would have to make sure he took that many grams of magnesium hydroxide. All right, now antacids B and C are each solution. So I kind of drew this little bottle here and noticed that one of the solutions is more concentrated. The top one is 0.25 molar and the bottom one is only 0.11 molar. So we're going to be wanting to end up this time with milliliters. This is like pouring like cough syrup or some other medication that's a liquid. You don't need grams, you need to know how many milliliters or how many ounces you need. So we're going to start off with the same given, which is that Mr. Beaker still has 75 milliliters of acid in his stomach. It's going to be nice and long again. So, and we're still going to convert this into liters. And then we will use the molarity of the acid again at 0.16 molar to convert to moles of acid. So for every 1 liter of acid, there are 0.16 moles of acid. And then we're going to use the same mole ratio between the acid and the base again. So for every 2, I don't know what's going on with this label up there. Oh, just jammed them together. Okay, 2 moles of acid to 1 mole of base or magnesium hydroxide. This right this time. And then this next we will use the molarity of the magnesium hydroxide, which in this problem is 0.25 moles per liter. So 0.25 moles of magnesium hydroxide. Should probably use the right amount of digits that it gave me per 1 liter of magnesium hydroxide. And then finally, to convert to milliliters, we'll say that for every 1 liter of magnesium hydroxide, we have 1,000 milliliters of magnesium hydroxide. So when we calculate this out, we will get 24 milliliters of magnesium hydroxide. That's like a decent sized sip. So there we go. And we'll notice that all of our units, magnesium or milliliters of acid, liters of acid, moles of base, liters of base will all cancel out, and then we end up with milliliters of magnesium hydroxide. Okay. Now before we do the third one, if you imagine that you are going up to a medicine cabinet and there's 2 bottles of cough syrup. One is concentrated, one is diluted. Can you predict which one you would have to take more of to make it help you? And then we'll kind of use that here. Well, Mr. Beaker, do you anticipate that he will need to take more of antacid C or less of antacid C? And we'll revisit that once our math is done. So we're going to start out again with the given, which is that Mr. Beaker has 75 milliliters of acid in his stomach. Oops, Big, long problem. And 1,000 milliliters in a liter and for every liter of his stomach acid, again, we're going to use that same concentration from up here, 0.16 molar. So that same concentration. 0.16 moles of HCl per liter of HCl. And again, we'll use the same mole ratio between the acid and the base. Again, up from the balanced equation, this 2-to-1 business up there. So 2 moles of acid to 1 mole of the magnesium hydroxide base. And now this time we're going to use the concentration of the magnesium hydroxide, but in this problem it's a weaker or less concentrated, lower molarity solution. 0.110 moles per liter. And then for every liter, running out of room, for every liter there's 1,000 milliliters. And when we do that math, we end up with 54.5 milliliters of magnesium hydroxide. So if Mr. Beaker decides to take antacid C here, he's going to have to consume 54 milliliters, over double the amount that he would have to take if it was antacid B. So look at the pictures of these two acids, the amount of black dots here, whoops, and notice that if the antacid is more concentrated, he's going to have to take less of it, but he has to take more of the diluted antacid if he wants to neutralize the acid in his stomach. So there are the three problems, three answers. If he wanted to take the first antacid, he'd have to take 0.35 grams because it's in tablet form. The second antacid, he'd have to take 24 milliliters. And the third antacid, he'd have to take 54.5 milliliters. So we'll go ahead and cancel out to show that our units are all good the whole way through. And that about does it.